So now let's go to the key elements of a genetic algorithm. Remember, a genetic algorithm is inspired in this process that I have just explained. So let's see. First, we need an initial generation. These are the initial generation of individuals. Each individual is a possible solution of the problem. In this case, we are using the snack-sack problem. So remember that a possible solution to that problem is a certain combination of 5 bits. In this case, we have 6 possible solutions. And this is the initial generation that usually is generated randomly. We generate a certain number of random solutions, and we call this the initial generation. So in this context, in the context of a genetic algorithm, an individual is the same as a particular solution. In this case, we have 6 particular solutions, and also it's a synonym of a chromosome. We call this a chromosome. So in order to set up a genetic algorithm, we need a model for the chromosome, a way to represent a solution to the problem. The chromosome model is the way to represent a particular solution to the problem. In this case, the chromosome is very simple. It's a set of 5 bits. And in the case of the air traffic problem, the chromosome is a set of 5 values, not bits. In any case, our genetic algorithm needs a chromosome model and an initial generation, usually generated randomly. In this case, 6 individuals. Okay, now we need a fitness function. It's a function that assigns a score, a merit, to a given solution. In this case, for instance, in the case of the snack-sack problem, we know that the function is just the total value of the elements that are put in the snack, in the snack-sack. In this case, the value is $5, but in this case, it's 15. Better solution. In this case is a ground solution, a very bad value. The function in this case would give us a very bad value. Okay, so we need a fitness function that tells us which of the individuals are better than others. Some of the individuals would have a very high score, for these ones, and some other individuals will have a very low score according to the fitness function. Okay, this is the second element we need to set up the genetic algorithm, the fitness function. Then we need a selection criteria. So how do we select individuals for reproduction? We need couple of individuals to reproduce and to have children. And the way we decide how do we make the pairs, the couples, the way is the selection criteria. And you have a lot of different selection criteria, but always they must be inspired in the way the nature works. For instance, in this case, this is a very simple example that we could call the law of the Lion King. Imagine that in this generation, the best individual is this one, according to the fitness function. This is the lion of the group, the Lion King. So the Lion King can select any female he wants for reproduction, and he can select as many females as he wants. He can reproduce with this one, with this one, and with this one. other lions do not have so many opportunities for reproduction, but the Lion King have a lot of opportunities. So this could be a selection criteria. The best individual can reproduce, can be coupled with as many individuals as we want, and then the second to the best is coupled, is paired with not so many, and so on. This is just a possibility. You might find, you will find in the papers, in the literature, a lot of very different criteria, but always you have to mirror in some way what is happening in the nature. So we need the selection criteria, and then the next step is to fix the reproduction criteria that we will call the crossover criteria. So once we have a couple that we have decided according to the selection criteria, we have a couple. Okay, this is the Lion King and this is the female in this occasion. Okay, we have a couple. So how do we build the children? In this case, a very simple crossover criteria is to take the chromosome of the parent, of the father, and split into halves, and to take the chromosome of the mother and also split into halves, and then to build one of the children. They will have twins. They will have two children, twins. So the first one will have the first half of the father and the second half of the mother, and the second twin will have the first half of the mother and the second half of the father. So we have twins, and both inherit the features of their parents, some bits of the father and some bits of the mother. Okay, this is just a particular way, a particular crossover criteria, but there are many others that you can learn from the literature. Then, next step, we have already a new generation. In this case, the new generation also has 6 individuals. That is the result of Lion King having children with 3 females. The Lion King selects 3 females, and with each of them he has twins. So 6. You already have the next generation. But then there is a mutation that could work as follows. We select randomly one of the elements in the next generation, only one, and then we select one bit of the chromosome. In this case, this bit, and then we change the bit. If it was a 0, then we put a 1. And if it was a 1, then we put a 0. This is the mutation. We can have a more aggressive mutation, and instead of selecting only one random individual, we can select 2 individuals. So more aggressive mutation. This can be a parameter of the genetic algorithm, a lower mutation ratio or a higher mutation ratio. Maybe a higher could give better results or not, I don't know. So we have to implement a mutation criteria. And finally, we have to decide when do we stop the iteration, because when we have the next generation, then we repeat the process to obtain a new next generation, and then a new one, and so on. And so how many iterations? What is the criteria to stop? Maybe the criteria is just to run this for 1 million iterations, maybe, or maybe the criteria is to repeat that until we get one solution. In the next generation, there is one solution as good as whatever you want. Maybe you have a criteria for a solution good enough in order to stop the process. So these are the elements we have to fix in order to set up the genetic algorithm: the initial generation, the chromosome model, the fitness function, the selection criteria, the crossover criteria, the mutation strategy, and the criteria to stop the iteration. Now in the next video I will show you a particular example, already in a program, in my computer program, and you will see how do we implement all these elements in a specific case.